Yes, this is section B. Yes, we have to attempt only 3 questions on 30 marks. It means that every question has 10 marks. But we are going to collect all section B without skipping any question. Yes, let us begin on question number 16. It said that the diagram below, figure 1, shows an object 2 cm tall placed at 6 cm away from a convex lens, or known as converging lens, of focal length of 3 cm. As you see, this is a diagram. You see that this is the focal length. The focal length is 3 cm. As you see, from one line to another one, there is 1 cm. As they have said that this is 1 cm, 2 cm, and 3 cm. As you are trying to see, this is going to be 4, 5, and 6. You see that your object is placed at 6 cm. Yes. Question number A. Copy the diagram and draw the lay diagram to scale. Use the graph paper provided at the end of your answer booklet to illustrate the image of object. Yes, to illustrate the image of object. Only to draw the lay diagram, you will be having 3 marks. Now B. From the graph, don't use a calculator, determine the I image position, II size of image, III property of the image obtained. Number C. Give names of 2 optical instruments that use our questions. Question A. Copy the diagram and draw a lay diagram to scale. Use the graph paper provided at the end of your answer booklet to illustrate the image of object. Yes, this is A. We are going to draw the diagram according to the rules of lay diagram for lenses. We know that the first rule says that when the lay is parallel to the principal axis, it will refract through focus. Yes, to refract through focal point. And number 2, when the incident lay pass through the center, it will continue without deviations. And number 3 is that when the rays pass through the focal point, it will refract parallel to the principal axis. Those are 3 rules that we are going to use so that we can find the position of our image. Yes, let's go. Yes, as you see, this is the first ray which is parallel to the principal axis. The refraction is through focal point. Number 2, the ray which is passing through the center, it has been continued without deviation. And number 3 is that when ray is passing through the focal point, it will be refraction parallel to the principal axis. So we will look where those 3 lines are meeting. Yes, the intersection of those 3 lines. The intersection of those 3 rays. The intersection of those 3 refracted rays. Yes, is where we are going to find the image. As you see, our image is inverted. Yes, our image is inverted. Yes, question B to say that from the graph, don't use calculations. Determines the I image position, II size of the image, I3 the property of image obtained. Remember, they said by using graph. So we're going to see the graph that we have seen, and then after here we have to see the image position, the size of the image, and the property of the image. Yes, they said to use the graph, but also you can use the calculations, but you have to respect the rules that they have said. You have to use the graph, but I can show you the second way of using calculations. Let us begin by using graph. So when you try to look clearly, you see that the focus is at 3 and the position for object is at 6. And remember that C is 2F. It means that to find the center, you have to take the focal point and you multiply by 2. So you see that the object is standing at C. Remember, once an object is standing in the center, also the image is found in the center. This implies that the position of image also will be found at 6. Yes, that's one. The second one is the size. The size also will not change because the object is standing at C. Remember, when object is at C, according to the property, yes, the image position is the same as the object's position. Even the size are equal. It means that also the image will have 2 centimeters of height. The second way, you can use calculations. According to the equations, you know that 1 divided by V, this is the image position, plus 1 divided by U, this is the object position, is equal to 1 divided by focal length. Yes, and remember, the focal length is positive when you have converging lengths, and even V is positive when you have the Leo image. Yes, so from here we cannot determine the sign of V because it's what we are going to calculate. Yes, so according to the formula, we get that 1 divided by V plus 1 over 6 is equal to 1 over 3. Our calculations, if we put to the common denominator, it will be 2 minus 1, and finally we find that V is equal to 6. You see that as U is equal to 6, also V is equal to 6. Yes, and as we have said, as we go to V which is positive, this implies that V as it positive, this implies that the image is Leo because I've seen the positive value of V. Yes, so according to magnification equation also we can determine the positions, we can determine the height of image. We know that according to the magnification, V divided by U is equal to HI divided by HO. Remember that V is position of image, U is position of object, HI is height of image, HO is height of object. Yes, this will be equal to 6 centimeter divided by 6 centimeter will be equal to this one. Finally, we got HI. So as a solution, we have gotten that the image position is 6 centimeter, the size of image is 2 centimeter, and characteristics of the image, have seen that the image is Leo because our view was positive. The image is inverted as you see. Yes. Next one, they have the same size as the object as it located at 2F. Yes, they have the same size. Yeah, let us go for the next question. Let's go for question 17. Yes, in addition to your knowledge and skills, use the concept of the state of equilibrium in relation to the position of the center of gravity to answer the following questions. Remember, they have said that you have to use the relation to the position of the center of gravity. Yes. A. Explain the following types of the static equilibrium: neutral equilibrium, stable equilibrium, and unstable equilibrium. Remember, they have said that you have to use the relation to the position of the center of the gravity. Yes. B. They said the diagram below shows 3 solid blocks made of the same wood A, B, and C with their cross-section area resting on horizontal table, as you see A, B, and C. And the question goes by, list the block in order from the least table and justify your answer. Yes, you have to list them from least table and have to justify why have you chosen an object to be more stable than another one. Yes. Question number C. Observe the following diagram, figure 3, and specify the type of equilibrium for each spherical object on board A, B, and C, according to the knowledge you have for the state of equilibrium of an object. Yes. You have to specify the types of equilibrium for A and B and C. Yes. Let us go and correct. Yes, back to A. They say we have to explain these types of equilibrium according to the position of the center of gravity. The first one is neutral equilibrium. We know that an object is in neutral equilibrium. Any slight displacement for that object doesn't change its level of center of gravity. We say that that object it is in neutral equilibrium. And we say stable equilibrium when any slight displacement an object is turned back to its original positions. Yes. And unstable equilibrium is when any slight displacement the level of the center of gravity of an object to be high. Yes, you will say that that object is in unstable equilibrium. Yes. Yes, those are what we have said. Neutral equilibrium is the state of equilibrium which occur when a simple object is displaced in such position such that any slight disturbance effort would not change the level of the center of gravity. Yeah. And for stable equilibrium is the kind of equilibrium that occur in a simple object placed in such position that any slight disturbance effort will raise its center of gravity. Yes. And the unstable is types of equilibrium that occur when a simple object is placed in such position that any slight effort will lower its center of gravity. Yes, those are solutions. And let us continue on. And B, you have to align those diagrams from the one which is least stable. And then as you see that A is unstable because any slight displacement A can fall down without coming back. And as you see, C is neutral and B is more stable. Yes, it's obvious. A is least stable, it's followed by B. The one which is more stable is B. The reason why you can say that B is more stable, you can back to the characteristics of an object which is unstable. It is characterized by the low center of gravity. That's one. The second one is a big base. Yes. And the third one, any slight displacement make that object to come back. Yes, to go and back and come back. Yes. So those three characteristics shows that B is more stable than C and A. Yes. Yes, as you see, A is least stable followed by C, and the one which is more stable is B. Yes. And the reason, the lower is the center of gravity, the more stable the object. Yes, it's what I've said. As an object has the low center of gravity, this is more stable than any other object. Yes. Also, they say that the greater base of support, yes, as an object is having the big bases, it will be more stable. So back to C, what we have to do here, yes, we have to specify the types of equilibrium. As you see, A is stable because then slight displacement, if you move this object A to it will turn back to its original position. This A is more stable, while B is unstable because any slight displacement B will go without coming back. Yeah, But C is neutral, because when you try to see, the center of gravity will be in center at this point. If you try to displace this C to a lower and lower and lower, but the center of gravity still will be in center, it will not change. That makes C to be neutral. Yes. A is stable, B unstable, is neutral. And those are the solutions for question A. According to A up to C. From A up to C. Those are the solutions. Yes, let us go for question 18. Yes.
And B, a student used the following apparatus to demonstrate pressure difference in water. The apparatus is hollow and has 3 short tubes at different depths. The student completely filled the apparatus with the water. Water comes out through all the 3 side tubes, you see. The first tube, the second one, and even the third one. Question here is copy the diagram and draw the path followed by water. Yes. You have to copy the diagram and draw the path followed by water. You will expect to see from inside tube. The second one, describe the path of water from the side tube shown in the diagram. Number last, why does it fit balance force when it is submerged in liquid? Begin with question A. How do you tell that an object submerged in sink or float? We know that an object can float or sink according to its density or the buoyancy force. Yes. According to the density, we know that if the object have the great density than the density of water, object will have to sink. That's what they have said. Yes, and when the object have less density, if the density of an object is greater than the density of water, that object will have to sink. And we know that if the density of an object is less than the density of water, the object has to float. That's what they have said. If the density of object is greater than the density of water, the object will sink. Or if the density of object is lower than the density of water, the object will float. And also you can answer this question according to the buoyancy force. Yes, or upthrust. We know that if the upthrust due to the water is greater than the weight of object, the object will float into water. We know that upthrust force the force of water that's pushing everything that's submerged into the liquid toward upward. Yes, you know, as that force is greater than the weight of object, we understand that the object have to float. Yes, let us continue with B. Yes, let us look to this diagram. You see that this is a diagram of water, and this is the first tube, the second tube, and first tube. And let us see the depth of the first tube. You see that from the top up to the first tube, you see this is the first depth, and from the top to the second tube, this is the second depth. From the top up to the third tube, this is the third depth. And as you see, for the depth 1 there is pressure 1, for the depth 2 there is pressure 2, and for depth 3 there is pressure 3. And we know that the pressure is directly proportional to the depth. This means that as you are increasing depth, also pressure will increase. As the formula said, the pressure in the fluid is equal to the density times by gravitational acceleration times by depth. So you see that depth 1 is less than depth 2 and less than depth 3. This means that the pressure 1 also will be less than pressure 2 and less than pressure 3, as I've said. So this makes us see the following diagram. As we have said that for the tube 3 there will be big pressure, the water will come out and sweat far away, and the following one will be the tube 2 and the last one will be the tube 3. You see that the pressure of water for the tube 3 is very big than tube 2 and tube 1 according to how water comes out from the tube. You see that tube 3 water comes out and far away. The following one is tube 2 and the last one is object field buoyancy force when it is submerged in liquid. So it has solutions. We know that when an object is submerged in fluid, it will try to sink, and as an object is moving deeper, it is increasing the depth. And as you have seen, so that the pressure in the fluid is directly proportional to the depth. As you're increasing the depth, also the pressure have to increase. Which means that as it's moving deeper, there will be the big pressure. Yes. As you see, because the deeper underwater, the higher the pressure. This is due to the difference between pressure exactly on the top side of the object and the pressure on the bottom. It's understandable that the pressure at the top will be very less, and at the bottom the pressure will be very big. As to the bottom will be having the big depth. So you understand that as you're moving deeper, the buoyancy is very high, is increasing. As you're moving deeper, the water is trying to push toward upward. Yes, that's why an object as it is sinking, it will experience a buoyancy force or upthrust. Yes, thank you. Heat capacity and specific capacity of substance. Yes, we have to give it a difference. We know that when we say heat capacity is the amount of heat needed to raise the temperature of substance by 1 Kelvin. Yes, the amount of heat needed to raise temperature of a substance by 1 Kelvin. Yes, and you know that the formula of heat capacity, you have to take heat divided by the change in temperature, and the unit is joule per Kelvin, while specific heat capacity is amount of energy needed to raise the temperature of substance of 1 kilogram by 1 degree Kelvin. Yes, that is specific capacity, and the formula, the specific heat capacity is equal to the heat divided by mass times by the change in temperature, and the unity is going to be joule per kilogram Kelvin. Yes, that's what we have said. We say that specific capacity is amount of energy needed to raise 1 unit mass. Yes, that is the definitions. Material by a degree Celsius, and the unity is joule per
degrees Celsius or joule per kilogram Kelvin. Yes. So according to formula, as I've said, according to formula, you see that specific heat capacity equal to Q divided by mass times by the change in temperature, while heat capacity is equal to Q divided by the change of mass. This Q stands for heat. Yes. Let us go for question B. The following question: describe how the following modes of heat transfer take place. The first one is conduction of heat, the second one convection of heat, radiation of heat. So we have to describe how those types of heat transfer, how they take place. Yes, let us go. So conduction, we know that conduction is a heat transfer between two materials that are in direct contact. It mostly happens in solid. You understand that? It follows the vibration of molecules so that it can take place. You know that when one molecule get it from the power source, get agitated and begin to vibrate, and once they vibrate, it agitated the neighboring at the last end of the molecule become agitated. So that's how heat can be transferred to the conductions. That's why they say transfer from water to the cold parts in the solid, from one molecule to another molecule as the result of vibratory motion of molecules. That's one. And convections, they happen through fluids. If I say fluid, you have to understand the gases and liquids. And the convection to take place, they must be faced what we call convection current. In a convection current, for example, let us take gas. When the gas that are closer to the heat, yes, the density become very less. Yes, you understand, as the density of the gas become very less, which is closer to the heat, it will try to float on the gas which has the big density. That's why the colder gases will come to the heat, and the hot one moves away. Yes, it moves up and the cold moves down. You understand that circle is what we call convection currents. And once you have a convection current, the process of that heat transfer will be convection. That's why they say the process, the heat transfer in the liquid and gases. Remember that you have said that liquid and gases, they are fluids, from a region of high temperature to a region of low temperature due to actual movement of molecule or due to mass transfer. Yes. Number last is the radiation. So if I say radiation doesn't need any medium of transfer, any medium of propagation. That's why they say that radiation heat is a process in which heat is transferred from one body to another without involving a molecule or the medium. Yes, you can understand. That's why I've said that for radiation doesn't need any medium of propagation. You understand that for conduction you need two substances to be in contact so that it can propagate from one to another one according to the vibration of the molecule. For convection you need fluid, where you can need gas or liquid. But for radiation you don't need any medium of propagations. Yes. Let us continue with the next question. The vacuum flask. This figure has 5 label features and each one described to reduce heat transfer. Analyze the figure 5 shown above and answer the sub-question below. Yes, let us see the figure. Yes, you see the figure. This is the vacuum flask, as you see. That is the vacuum double over the wall. The first question is that which labeled feature of the vacuum flask reduces heat transfer by both conduction and convection? It's understandable. Yes, it's understandable because it will be vacuum. Remember that vacuum is between two surfaces. The one is one which is slivered and the inner one which is slivered also. Between the inner and the outer one, there is the vacuum is hard. So you know that the vacuum Yes, it's one part that you have been asked, because conduction and convection need the medium of propagation. Remember that for the conduction they need the vibration of molecules. Yes, that have to be in action. But also for convection we need fluid. It can be liquid or gas. So if we put vacuum inside here between two walls, it means that conduction can neither take place nor convection. Yes, let us continue for B. Explain how these feature of the vacuum flask reduce heat transfer by both conduction and convection. This is what we have said. I've said that conduction and convection need medium of propagation. So as we have vacuum inside, there will be no heat, no heat transfer. Yes, the next question is that which labeled feature of the vacuum flask reduce heat transfer by radiation? Yes, for this we know about the black body and shiny object. We know that a black object is a good absorber of heat, while the shiny surface is a good emitter of heat. So if here we have the slivered surface, it means that as we have slivered surface, as the heat comes closer to the surface, and remember the surface is slivered, it means that it's the shiny object, and remember that the shiny object is a good emitter of heat, so it will be reflected back. Yes, that's why you understand that radiation will not take place. So we will say that the part that can help to reduce heat transfer by radiation, it can be slivered surface. Yes, that's it. So what we have said, that the vacuum is one part. It's play a role for reducing heat transfer by conduction and radiation. So here they explain the vacuum is lack of atom. Without atom, we will examine the conduction and convection, as we have said. And as we have said, it's a slivered inner surface, as I've showed you, because it reflects radiation and infrared toward the liquid. The liquid, as I've said, that the shiny surface is a good emitter of heat, as I've said. As the heat strike on the silver surface, we deflect back. Yes, let us continue with the next question. Yes, we go on question number 20. You see that it's electromagnetic. Yes, it is electromagnetic induction. Yes, a coil of the wire is connected to a sensitive galvanometer, as shown in the figure. You see, this is a galvanometer, this is a coil, and this magnet. What is observed on the zero center galvanometer when the bar magnet is stationary in a coil? Yes, we know that the EMF or the voltage is induced in a coil once there is relative movement between a conductor and magnet. So if the magnet is stationary, it's not moving, it means that there is no EMF. So it means that the point of galvanometer will be standing on zero, will be at zero position. Yes, B. What is observed on is center zero galvanometer when the bar magnet is moved toward the coil? Yes, you understand that once the magnet is entering into the coil, there will be the relative movement between this conductor and the magnet. You understand that the EMF will be induced. Yes, so the point of galvanometer will deflect in one direction. This is what will happen. To show that there is EMF induced, the point of galvanometer have to deflect in one direction. Yes, the next question, what is observed to the zero center galvanometer when the bar magnet is moved away from? Yes, you understand that if the magnet is moved away, also the point of galvanometer will deflect but in opposite direction. You understand that the current will change the direction, because here we are dealing with the AC, the alternating current. So that's why the point of galvanometer will deflect in different direction from the first. Yes, the next question, what is caused the observed result made when the magnet is moving towards and when they're moving away from the coil? It's understandable. What is causing that to happen? What is causing that deflection to happen is because there is the relative movement between a conductor and a magnet. Yes. The next question. Suggest two ways that may be used to increase the, yes, it's understood. We can increase the number of turns of the coil. That's one. The strength of magnets. Yes. And even the area that the magnetic field line are close with. If the area is big, we understand that the large amount of the magnetic field lines will enter through. Yes. Yes, let us go for C. A transformer is a device based on the principle of electromagnetic induction. Yes. Name one electrical device that uses a transformer. Radio, telephones, and so on. Yes, the next question. The input coil of transformer, 200 ton of wire, and is connected to 230 volt alternating current supply. What is the voltage across the output coil when it has? Oh, yes, we have the input number of turns 1, have input power, and we are asked to calculate the output power. You have the number of turn 2. Simple. We have to use the equation of transformer. Let us go. You see what I've said before, that there is no deflections. Yes. For the second, there will be the deflections in one direction. Electromotive is induced. For the second, deflection of galvanometer needle. Also in another direction. But let us go for the next question. Yes. Here they said according to what may cause the EMF to increase, you see there is the number of turns and magnetic flux. These are the strength of magnet. This is what may cause the EMF to foresee. Yes. As to do that question, you have to use the transformer equation. We know that the voltage secondary divided by the voltage primary will be equal to the number of turns of secondary divided by number of turns of primary. Yes. So remember that the secondary is output, primary is input. Yes, as you see, if we do the cross product, is simple. You see that we found that the voltage secondary will be equal to the voltage primary times by number of turns secondary divided by number of turns primary. That's what we have done. As you see, the solution is going to be 690 volt. Yes. Next question. What is the benefit of using transformer in transmission of electrical power? It's understandable. The importance of transformers to step up the current or to step down. Yeah. Yes, that's what was said, to step up and down the voltage or the current. Yes, thank you very much, ladies and gentlemen. Yes. See you on next session. We'll be collecting section A of this exam. Thank you very much. Have a nice day. And if you like this video, please remember to subscribe and share to your friends. Yeah, you may share it to your friends so that anyone can find the solution of different exam here, because we collected many exams. Yes, thank you.